Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, with this paper published on September 29, 2025, about 2 days ago. The big hook is simple. It delivers up to 14.8 times lower inference latency without sacrificing quality, and it can generate 2,160 by 3,840 videos on a single GPU. The paper is titled DC-VideoGen, Efficient Video Generation with Deep Compression Video Autoencoder, and as we'll see later, the results are really impressive. Beyond speed, it uses a deep compression autoencoder with a chunk-causal design and an AE adapt-V transfer scheme, adapting WAN 2.114b in only 10 GPU days. Figure 1 shows that the system keeps visual quality while cutting latency, so single GPU generation at 2,160 by 3,840 becomes practical. The top montage presents sample frames at 720p, 1080p, and 2160p that look crisp and temporally consistent. The bottom left chart plots latency versus resolution, highlighting about 15 times speedup at the highest setting. The bottom right chart reports latency versus number of frames, showing roughly 14 times acceleration at the longest sequence. Alright, Figure 2 shows how the system speeds up generation by moving the diffusion model into a smaller latent space and then restoring quality with AE adapt versus AE adapt Vi aligns the patch embedder and the output head, so the pre-trained semantics transfer cleanly. On the left, the diagram contrasts the base autoencoder with DCAEV, indicating token reduction that enables faster inference. On the right, the bar chart reports only 10H100 GPU days to adapt the 14B model. That corresponds to about 230 times lower training cost. So, Figure 2 outlined the adaptation pipeline. Figure 4 illustrates how chunk-causal temporal modeling changes the autoencoder's information flow. The left panel shows non-causal modeling, which connects all frames both ways and risks poor generalization. The middle panel shows causal modeling, which only allows past to future, so reconstruction suffers under deep compression. The right panel shows chunk-causal modeling, where frames are grouped into chunks with bidirectional links inside each chunk, and causal links across chunks, which improves quality while keeping long video generalization. Alright. Table 1 shows that the deep compression autoencoder delivers the strongest reconstruction quality at high compression. The highlighted DC-AEV rows beat prior autoencoders on peak signal-to-noise ratio, structural similarity, and learned perceptual image patch similarity, and also lower Fréchet video distance, which is a score that reflects temporal realism. The gains hold from 48 times to 384 times compression. These results support the chunk-causal design's ability to preserve detail while shrinking tokens. Okay, 2 takeaways stand out. The chunk-causal deep compression autoencoder slashes tokens while keeping fidelity, and AE adapt-V moves large diffusion backbones into that space with only about 10H100 days. The impact is big, about 8 to 15 times faster generation and practical single GPU 4K video, opening the door to accessible, high-quality video creation. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.